So good afternoon, everyone. Today we are going to talk about Section 4, Indefinite Integrals and the Net Change Theory. Now first, before we introduce the indefinite integrals, let's recall the fundamental theory of calculus we studied in the Section 3. Especially, let's recall the Part 2, Part 2. Part 2, if we are going to evaluate the definite integral from a to b, then we can find any antiderivative of this small f. We write it as big F. Then this big F will be the difference of this big function, big F evaluating at the two endpoints. And also you can write the notation as a vertical line here, from a to b. That is the same as fb minus fa. Here, fx, usually we use the particular antiderivative, and we explain why, right? The general antiderivative, u plus the constant c, the constant c will be cancelled if you do the subtraction here. So that is the FTC Part 2 help us to evaluate the definite integral, right? And we know that f prime is the small f, which means big F is called the antiderivative. And also we reviewed several tables of the antiderivatives. We know for this small f, if it's x to the n, x to the exponent n, it's easy to figure out its antiderivative when n is not minus 1. Or when fx is sine x, cosine x, second square, then it's also easy to find its antiderivative. Or fx is a natural exponential, or it's 1 over x, then we can also work out this type of functions antiderivative, right? So that is the antiderivative evaluating at the two endpoints, then take the difference. We can work out this one. And also we can use the notation for the antiderivative, a convenient notation for the antiderivative. We will write in this way, So let's check this integrals, Let's check this integral. Comparing with the definite integral. Here, this integral without lower and upper limit, right? So we call this one is the indefinite integral. Indefinite integral without the lower and upper limit. The other part is the same. This is the integral sign. This is the integrand function. Dx indicates the variable is the x. So here, this indefinite integral represents the antiderivative and represent the antiderivative with the general one, the general antiderivative. So that means the derivative of big F gives the small f. So what does this indefinite integral notation means? That means the general antiderivative. We know what we call the general antiderivative, right? General antiderivative means you should plus the constant c. You should plus the constant c. So this symbol, this symbol is called indefinite integral, and we know it's a notation for the general antiderivative. Now let's comparing, Let's comparing this one with the definite integral we talked about before, We talked about before. Here, directly to see, it's directly to see with in the indefinite integral, there is no upper and limit. But we need to understand what does this mean, right? This means the antiderivative for the integrand function small fx, right? Small fx. And this is something we are going to focus in this section, The indefinite integral. This is something we are going to focus in this section. Indefinite integral, which means antiderivative, the general antiderivative for the small f. Now, let's distinguish between definite integral and indefinite integral. Okay. Here, let's check this one. Okay. Let's check this one. The definite integral, what we studied. Okay. The definite integral is this one, from a to b, fx dx. And at the very beginning, how can we understand, how can we define this definite integral? That means the area under the curve fx from a to b, right? How to define this definite integral? That is the area under the curve f from a to b. So we know this is the number. Make sense? The definite integral is the number. It can be positive or negative. It's a net area. Net area, it can be negative. So it's a number. Then what does this one mean? What does the indefinite integral we are talking about? This one denotes the big F. What is the big F? The general antiderivative. Is this one a number? Of course it's not. Okay? Of course it's not. This is a antiderivative. It's a function. Antiderivative is also a function. And what is the connection between small f and big F? The derivative of big F gives small f, right? So the indefinite integral represents a function. It's a function of x, right? It's a function of x. And actually, it's a family of functions. So a definite integral, this symbol, okay, this symbol is a number, represents the area, right? Represents the net area. And this indefinite integral, this symbol is a function or family of functions. Family of functions, which means we do plus c. Okay, it should be the particular antiderivative plus the constant c. So plus the constant c, that part, the constant part, denotes that families of function, which means you shift the particular antiderivative upward or downward by c unit, right? So it will be why we call the family of functions. It should be the particular antiderivative, okay? Antiderivative plus c, right? Which implies shifting the particular antiderivative either upward or downward by c unit. So here it is a function, right? This is a function of x, right? Antiderivative is a function of x. But definite integral gives a number, okay? Gives a number. So try to be careful, okay? Try to be carefully to distinguish between those two integrals. And we will focus on indefinite integrals. Now, let's recall the FTC Part 2, okay? FTC Part 2. If f is continuous on AB, then we have the definite integral from a to b fx dx. That will be its antiderivative big F evaluated at the two endpoint AB, then take the difference, right? Now we have a notation. We have a new notation for the indefinite integral. Okay, for the indefinite integral. So we can represent this fx as the indefinite integral fx dx, then evaluated at a and b, take the difference. So we can also rewrite the FTC Part 2 in this way, and we understand this indefinite integral represents the antiderivative, right? It usually represents the general antiderivative, okay? General antiderivative evaluated at a and b at the two endpoints, then take the difference. So here, that means you find the antiderivative, the function first, and then take the difference of the antiderivative at the two endpoints. That gives the definite integral. So here in our textbook, from section 1 to section 3, we talk about at the very beginning of chapter 4, section 1 and 2, we give the definition of the definite integral, right? Definition of definite integral. We introduce the definite integral first, and then when we come to the section 4, we introduce its indefinite integral. That first, this is the area we understand, right? Definite integral. Now we came to the indefinite integral. We understand that this is the antiderivative. This is a function. But in some other textbook, if you read more, some other textbook, they might introduce the antiderivative, the indefinite integral first, which is the function, right? The indefinite integral, which is the antiderivative for the integrand small f, and then they introduce the definite integral, just means the area evaluated from A to B. So it doesn't matter, okay? It doesn't matter which one goes first, but we understand they are different. Definite integral is a number. This one gives the function, right? This one gives the function or families of function about antiderivatives. So that is the way we rewrite the FTC Part 2, okay? FTC Part 2. Now next, let's see some tables, okay? Let's see some functions, indefinite integrals. So first, okay, let's check the first one. This is the antiderivative for CFX, okay, CFX. It's still called the constant multiple rule, okay, constant multiple rule, and it will be similar to the limit, and the differentiation part, okay, differentiation part. If you take the limit of c times fx, then you can move the c outside of the limit sign. Or if you take a derivative of c times fx, you can move the c, the constant, outside of the differentiation sign. Okay, so it's the same for the indefinite integral here. You can move the constant c outside. Okay, then you find the antiderivative for fx first. Now, second one, the indefinite integral for a constant k, okay, for constant k. So be careful, okay, be careful. For constant k, let me recall in the limit part, okay, when x approaches a, what is the limit for c? When x approaches a, what is the limit of a constant? The limit of a constant gives a constant also, right? And again, what is the limit? What is the differentiation? What is derivative of a constant? Derivative of a constant gives 0, right? Be careful here. The indefinite integral of a constant k, that should be kx plus c, okay? Kx plus c. So here, with those 4 k's, the plus c means general, right? Means the general antiderivative. We all did plus c, antiderivative. So indefinite integral k, that will be kx plus c, right? How can we check? If you take a derivative of kx, then you get the constant k, right? If you take a derivative of this part, this is my big F. This part is my big F. So you can check that the big F derivative will be k, right? Will be k. The constant derivative will be 0, so the f prime will be k. So you can check in another way whether your indefinite integral answer is right or not. Okay? So f prime gives the k, gives the integrand inside. Now sine x, which function? Which function gives its antiderivative? Minus cosine, right? Minus cosine plus c, right? Plus the constant. Secant square, which function's derivative gives secant square? Tangent x, right? Tangent x plus constant c. Secant x, tangent x, secant x derivative gives secant and tangent, right? Secant times tangent. And we all plus c, which means the indefinite integral, as I said, indefinite integral means the general antiderivative. So don't forget about the c, okay? Don't forget the constant part. So those will be easy. It's like we recall the derivative part, okay? Let's see more. So the indefinite integral of f plus g, of course, it will be the integral for each, then take the sum. And it should be true just minus, right? Just a minus sign. If it's minus f minus g, then that will be the integral, take the difference, right? It's the same here. Now next one, x to the n, the antiderivative. This is the case when n is not equal to minus 1, okay? Because here the denominator cannot be 0. It's trivial if n equals minus 1. So x to the n, the antiderivative should be x to n plus 1 over n plus 1 plus the constant c, right? And then cosine x, antiderivative sine x plus c, right? And those two, cosecant square, that gives minus cotangent, and cosecant times cotangent, that is minus cosecant. Those two usually we are not required in our course, okay? So you should be familiar with those three. That's enough, okay? And from here, actually we can see from all those tables, we can see this definite integral is the general antiderivative, right? This is the general antiderivative. We plus the constant c, general antiderivative. That is number 1. And this general antiderivative is a function, right? Not a specific value. It's a function of the independent variable x, right? If you use ftdt, that means it's a function of t, right? Depends on the independent variable letters you choose. So here I just mean it's a function of x, okay? General antiderivative. And how can you check your answer is correct or not? For example, here you just take derivative of sine, right? This is your particular antiderivative. You just take derivative of your particular antiderivative. You take derivative of sine x. Of course, sine x gives cosine x, which is the small f, which is the integrand inside the integral. Integrand, right? The function f inside is called integrand. So that means our answer is correct, right? Or you do plus c here. You do plus c here. It doesn't matter, right? It doesn't matter. Let me put let me write it in a clear way. So you check your derivative, the derivative of your answer, that is cosine x, constant part goes to 0. And this is exactly the integrand inside, right? Integrand inside. So that is indefinite integrals we go through with the tables, okay? Now let's see some examples. Example 1, find the general indefinite integral. Find the general indefinite integral for this example, okay? For this example. So you can take this one as fx minus gx dx, right? Now let's start, okay? Let's work out step by step. I'm going to ask someone to understand to answer the simple question we pop up in example 1. So here, the indefinite integral fx, you can take the first part as fx. Sorry, the minus is so large. Eraser. All right, 10x to the 4 minus 2 second square dx. So you can take it as fx minus gx, so that will be the indefinite integral for fx minus indefinite integral for gx, right? Let's work out step by step and trying to take some notes. And when you write those, don't forget the dx term, okay? No matter definite integral or indefinite integral, don't forget the dx term. So here, fx, there is a constant, right? This is, you can also take this one as a constant times a function. So you can move the constant outside. X to the 4, I'm going to ask someone to answer the antiderivative, the answer for this definite integral, and minus 2 second square dx. Right? We can also move the constant 2 outside. Let's call someone to answer those two parts to check whether students are available during the class time. Majid, are you available? What is the answer for the first part in indefinite integral? Majid, you are called to answer this question. What is the answer for this indefinite integral here? Let's call another one to answer the second part. Islam from mechanical major. Those two people, you are called to answer the indefinite integrals for those two parts. The first one and the second one. Okay, Majid gave us the answer, right? Okay, so he said the first one, let me change. Okay, so the first one should be 10. We keep the constant 10, and then the indefinite integral. Be careful, okay, Majid. As I said, maybe some other students will be the same answer as Majid. The indefinite integral means the general antiderivative. This sign in the tables we did, shall we plus a constant c or not? We should do that, right? We should do that. X to the 4, the antiderivative, particular one will be x to the 5 over 5. But indefinite integral, don't forget the constant, okay? No one else to try the answer for the second part? There is no reply, and also no reply in the Danmu for those answers. I just saw 2 students replied. Trying to be active during the class time to show your work. You follow the examples here. So second part, Islam, not available. So we saw some answers. Let's check. Okay, let's check. So 2 times the indefinite integral. Integrand is second square x. So we know tangent x derivative will give second square, and don't forget plus a constant. I just write c2. Okay, I just write c2. Now let's keep going. So will be 2x to the 5 plus 10 c1. Let me combine all the constant together, okay, as the last part. Change to my pen. Then sorry, here should be manners. Okay, here is manners. Now, here is minus 2 tangent x and plus 10c1 minus 2c2. So here, how can we deal with the constant? How can we deal with the constant 10c1 plus 2c2? Actually, we don't care about what is specific value here, okay? We don't care about what is the number you get here. We can just combine as a constant c, okay? We combine this term and use a constant c to denote that. So the final answer should be 2 x to the 5 minus 2 tangent x plus c. Let's check whether some students get the answer or not. Yes, some students get it. Okay, very good. So we combine here as just one final constant. Okay, just as one final constant. And if you go back to here, that is the indefinite integral for this function inside. So you put one constant. That is reasonable, right? There is no need to specify each. And finally, let's check. Okay, let's check whether our answer is correct or not. Now let me choose a different color in purple. So let's check whether my answer is correct or not. So let me take the derivative. So this part is called check in purple color. Okay, so let's take derivative of this function. Okay, of this function 2 tangent x plus c. Okay, plus c. So we get the answer is 10 x to the 4 minus 2 tangent x derivative will be second square, and then the derivative of a constant goes to 0. That is exactly the exactly the integral, right? That is we take the derivative of our final answer, then it's right. This is a good way to check your answer when you evaluate your definite integral, whether it is correct or not. And we don't care about what is c here. You write that's why I said there is no need to put specify of the constant. Just use one notation for the constant part, and the derivative of a constant, it's 0, right? It's 0. Now let's check the solution I typed here. So using our convention and table 1, we have, so they go through, they follow, they didn't separate it, okay? They just, so here 10, move 10 outside, indefinite integral x to the 4 minus 2 indefinite integral with second square, then we get 2. They didn't specify the constant for each term. We just use one constant to denote that. Okay? It's perfect and pretty easy examples. Now, let's check second one. Evaluate the definite integral. Evaluate the definite integral, which means we know the lower and upper limit. Right? We know the lower and upper limit. The lower and upper limit are given 0 and 12. Now, according to the FTC Part 2, we can follow the formula in this way. Evaluate the definite integral. We can work out the indefinite integral first, and then evaluate at 0 and 12. Right? 0 and 12. So we are going to follow in this way. Okay, we are going to follow in this way. So some of you can practice this one and get the answers. I'm just a little slow to make sure most of the students in our class, they can follow and they are able to take note. Okay. So for this definite integral, let's work out the indefinite integral for this function first. And it's pretty easy for x term and for sine x term, right? To find the particular antiderivative. It's pretty easy. So x should be x squared over 2, right? X should be x squared over 2. Then minus 12, what is the antiderivative for sine? Particular one should be minus cosine, right? Minus cosine. And then finally, you can plus the constant c, right? You can plus the constant c. But here, you can plus the constant c here. But later we will do the subtracting, right? We will do the subtracting at the two endpoints. So c and c will be cancelled out. So here, there is no need to write c, okay? Because we are going to evaluate the antiderivative at the two endpoints, 0 to 12, like that. So that will be actually x squared over 2 plus 12 cosine x evaluated at A and B. Now let's write it. Okay, let's write it. So when x is 12, step by step, okay, step by step. So it will be 12 squared over 2 plus 12 times cosine when x is 12. And then minus 0 over 2, right? When x is 0, 0 over 2 plus 12 cosine 0. And I believe some of you will give me this part in parentheses is 0. Be careful, okay? Be careful. And I already saw some students give different answers. What is cosine 0? Cosine 0 should be 1. So the part in parentheses is not 0. This term is 0, but the second term not. The second term will be 12, right? Second term will be 12. So minus 12. Here we got 6 times 12, 72. 72 minus 12, we get 60. Okay, we get 60 plus 12 cosine 12. Okay, and we are going to estimate the values. And by the way, we can check whether the indefinite integral is correct or not. Okay, let's do one more step to check it. Okay, to check it. So let's take the derivative of this function, x squared over 2 plus 12 cosine x here. So that will be x squared over 2, of course, the derivative is x. Then plus 12 cosine x, the derivative gives minus sine. So that is the function, right? That is the derivative result, which is the integrand inside. No problem, okay? No problem, which means the particular antiderivative we got here is correct, right? This part is correct. Now, let's check the solutions. So the fundamental theory gives the format, right? The fundamental theory gives the format. We work out the antiderivative. Particular version, there is no need to write the c, constant c, because it will be cancelled. And the final answer is 60 plus 12 cosine 12. And we need to evaluate the cosine 12, okay? And finally, we get the approximating answer is around 70, okay, around 70. How can you evaluate 12 cosine 12? Just use your calculator, okay? Just use calculator. If you ask me, then I'm also telling you use a calculator to find the cosine 12, okay? And let's check the graph, okay? Let's check the graph. And let me explain a little bit about the graph again, okay? The graph again, since now we studied both definite integral and indefinite integral. So here, this curve, okay, this curve is the integrand fx, okay. So this is the definite integral from a to b fx dx. Dx is the integrand, right? So here my integrand fx is this one. My fx is x minus 12 sine x. That is the curve shows, right? So what does this definite integral mean? That means the area under the curve f from 0 to 12, right? From 0 to 12. It's showing the curve looking like this one. And then we know the pink part above the x-axis, that is plus. The area sign is plus. And the blue part below the x-axis, the area sign is minus, right? So the net area of those four parts, the net area for the four part showed here, for the four part shown is approximately 70, right? Approximate 70. So that is the net area, right? So let's understand the definite integral. This is the net area. It's a number. It's a number, right? It's a number. And since we assigned some questions in the quiz, let me repeat the FTC part 1, sorry. FTC part 1, we define some other function we called gx. Now what is this gx? The way we define the gx is a to x ft dt. How can we understand this function gx? Gx is, we can interpret the gx. This is the new function, okay? So here, this curve is about f. No matter you use x or t, okay? It doesn't matter you use x or t as an independent variable. This is a curve about f. Then what is the gx we define in the FTC part 1? So the gx is called the accumulated area from accumulated area under ft from a to x. And as x is shifting, then this gx is changing, right? This gx is changing. For example, I can take my x here, right? I can take my x here. So what is gx? Gx will be the area minus plus minus. Take the sum of those three part area. That is gx. Gx is another function we defined according to FTC part 1, and that is the accumulated area from a to x. Depends on the x where you choose, right? Where you choose. So don't be confused about the integrand fx or ft with the gx here, okay? In the quiz, we assign some question like that. So be careful, okay? Be careful. I think it's almost time to take a break. Then we will start the second part of the next series, okay? So 5 minutes break, then we will be back.